Session is being recorded. I started now. 6 p.m. and we have how many students? Only 5 students. Okay, where we will walk today? So today we go to course material, no, content. Okay, now I have to show you where I am. Content. So now you see content. Our blackboard. And like every time when you start to see blackboard of our group, you see syllabus. And according to after syllabus, you see lectures. And we have to go to bottom. In some reason, you see this on the bottom, physics of music. Don't touch this. It's not for you now. Focus to lecture 16, linear momentum and collision, chapter 8. Linear momentum collision, chapter 8, we go inside. And now what we see? We see again syllabus. And today we work with the chapter 8. As we start to learn chapter 8 of your textbooks. So you see again syllabus, part of syllabus, with the topics, chapters, and problem for self-examination. I want to repeat again, student, you have to try to do this problems in additional to my quizzes. But quizzes I will check, but this I will not check. Check yourself. Okay, then you see section of the chapters, and after section you see videos. What we will watch, we will watch not all this video. We will watch some only specific. Another it will be a homework. And on the bottom you see lecture 16, class quiz 1 on the bottom. Maybe you don't see it, see only my screen now. I make this available for students. Make available. And I will put this quiz, what now located on the bottom, up. I will move up. I will move after first video. So we will start to work with this class quiz after first video. When first video gives us some initial information about topic of this lecture, so we will ready to do this quiz. So by this reason I move this quiz up. You see now. So what our first video will be impulse and momentum. So you don't know now what is impulse, you don't know what is momentum. After this video, you will know what is impulse and momentum. After this, you will be ready to do some question of this class quiz 1. And we will start together. Together with me, you have to start, all students. Don't wait when we will finish all total class. No, this is a part of our class work, to work with the quizzes, and I will check your success, and I will do conclusion, how I will change my lecture, what I have to add, what I have to subtract, for what I have to focus. So it was important to see how you solve problem, how you answer question of class quizzes, exactly in class, not like homework. Maybe homework I will give you But student, I don't see solution, meaning like I don't see work really, homework for you with the quizzes. It's not good. Try. Doesn't matter for beginning. What will be your answer? Correct or not correct? If not correct, we will work together. I will help to change wrong answer to correct answers to reach better grade. But if I don't see work, I cannot help you. I don't know
Hey,
how I can help you.
hey, Professor. For
Yeah.
lecture 15, quiz 1, there's a time limit on that one.
What quiz one?
Lecture
Timer.
15, quiz 1 has a like a time limit on there.
Okay, I will check. Okay. But we have another quizzes. Quiz one maybe, because I use special quiz one to work in class. Like today I work student. They have to focus to lecture 16 class quiz one. This lecture 15 class quiz one I want to use like attendance. If I see student work in this class to read this quiz, it means student was on the lecture, actively participate in lecture. If I don't see student some solution, it means it doesn't work in class. Okay, so let's start student today. So move on questions. Any questions? Any questions if you have? You can ask me now before we will start to watch videos. No questions. So now I see 12 students. Okay, not too much, but okay for you students. Together we'll watch first quiz. Everyone, which one do we have to do for attendance? No, first for attendance, main option. You have to have connection. Is first, but it's not enough because I see some made connection but don't do participation. So participation in class quizzes is a main part of your attendance. Participation in class quizzes. Homework quizzes, or somewhat I said, okay, it's class quiz, but you can continue at home. Okay, but you have to start in class, and I will check. Okay, so no more questions. So participation in class quiz is an important part of your attendance. Let we go. Impulse and momentum. Professor Dave.
Professor Dave here. Let's talk about impulse and momentum.
He knows a lot about the science stuff. Professor Dave explains.
In chemistry, we learned about the conservation of matter. Here in physics, we learned about the conservation of energy. These concepts can be extended to formulate another law, and that is the law of conservation of momentum. Momentum is a term we may be familiar with, but once again, we must learn the rigorous definitions of these words. And linear momentum is defined as mass times velocity, which will be represented by the letter P. Momentum is a vector quantity, as it involves a velocity vector being multiplied by the scalar value of the object's mass. This means momentum will be expressed with SI units of kilogram meters per second. In this case, our everyday use of the word is fairly accurate, and we might say that as a ball rolls down a hill, it will gather momentum. This is true because its velocity will increase as the force of gravity accelerates it towards the ground. The more momentum the ball gathers, the more difficult it will be to bring it to a stop, and an object in motion can therefore have a larger momentum by virtue of being more massive, like a huge boulder, or also by moving at high velocity, like a tiny hailstone or meteorite falling from the sky. If we consider a car in motion, it too will have a momentum equal to mass times velocity. And if you slam on the brakes to avoid a collision, the car will skid a certain distance because a force must be applied over some duration of time to bring a moving object to rest. The heavier the car and the faster it was moving, the greater this factor will be. A small force acting over a long time could do it, like if you take your foot off the gas and let the friction from the road slowly stop the car. Or a large force acting over a short time could do it, like firmly applying the brakes to the tires. The force that is applied multiplied by the duration of time that it is applied is called the impulse, which will be measured in Newton seconds. The relationship between impulse and momentum is summarized in the impulse-momentum theorem. It states that the impulse, F delta t, is equal to the change in momentum, or delta p, which can also be expressed as mv final minus mv initial. So if you apply some force to push an object for some duration of time, that object will gain a proportional amount of momentum. If an object loses momentum, it must be imparting some force to something else over some time period. Just as the work-energy theorem describes conservation of mechanical energy, the impulse-momentum theorem describes conservation of linear momentum. Another ramification of this theorem is that the force imparted on a moving object when it strikes some surface will be very large if the impact is instantaneous, and much less if the impact involves some time duration. If you fall off your roof onto the ground, it will hurt. But if you fall onto a trampoline, it won't be as bad because the change in momentum imparted on your body, instead of happening instantly, will be delivered over the entire duration of your contact with the trampoline surface as it stretches from the force of your fall. This is also why baseball players are taught to swing through the ball rather than stopping the swing upon impact, because if contact is maintained between the bat and the ball for as long as possible, the maximum possible force will be imparted upon the ball. In the case of an object striking another object, total momentum will be conserved through the collision, and the sum of the momenta of the two objects will be the same before and after the collision. The easiest example of this concept involves balls on a pool table. We will often observe that one ball has momentum while the other does not, and after the collision, the first ball has stopped and all of its momentum has been imparted onto the other ball. This type of scenario illustrates conservation of momentum. There is much more to discuss regarding collisions, which we will go over in the next tutorial. But first, let's check comprehension.
Okay, let's see. Okay, what? Given data, we know mass of objects, and we have initial velocity. Then we know force. Then we know final velocity. Question: how long? Okay, so we write equation: F times delta t equal mv final minus mv initial. You saw this equation before. So what we know? We know mass, we know v final, we know v initial, we know F. We have to find delta t. So they do mathematic job and we find delta t.
Thanks for watching, guys.
Okay, students. So let we focus to equation. What we have this. See, first equation is a definition of momentum. P equal mv. And you see P is a vector, momentum is a vector, and V is a vector. What does it mean? If we will use component of vector, so really we have this three equation for component x, for component y, for component z. Okay, the vectors. When we will focus to one-dimensional motion, so we can forget about this. We have x, y, and z, we have only x. But we have to know to if we have direction to positive direction of x, velocity and momentum have to be positive. If we have motion to opposite direction, to x direction, so momentum and velocity have to negative. Okay, so this is the definition of momentum. Then next we see definition of impulse. F times time. For some reason they write the delta t, it means change of time. So t final minus t initial. Sometimes we call this t, but no, for some reasons we call this delta t. Okay, so is the impulse. It's force times time, no, and unit of measurement Newton times second. Then we see what is relationship between impulse and momentum. Change of momentum equal impulse. So we can say that impulse influence to object and change momentum of this object. So what we see triangle, what does it mean triangle? It means we call this triangle delta. How it stands is a final minus initial. It means F times T final minus T initial equal P final minus P initial. P is a momentum. No, because P is a already know is a M times V, so F times delta T is mv final minus mv initial, where V is velocity, m mass, delta T is a time, F force. No, and of course, again, I have to focus you. F is a vector, V is, and V are vectors. V final, V initial are vectors. So I think we have to think, what is the direction of this velocities? What is the direction of this force? Okay. No. And if force equals 0, what kind of force? External force. So if you have two objects, maybe they interact with each other and they collide each other, but external force equals 0. And because external force equals 0, it means total momentum of this object doesn't change, because impulse equal total external total impulse equals 0. So if external force equals 0, we have law of momentum conservation. Total initial momentum equal total final momentum. This is the show equation like for two objects, object 1 or object 2. The sum of momentum object 1 object 2 equal sum of momentum object 1 and object 2 after anything. Collision, for example, of these two objects. But in condition, there is no external force. There is an internal force between this object, but not external force for some external object. Okay. No, as example. So now we're ready. So student, now go to quiz, what I give you, and start to try to answer of first questions. So what kind of quiz you see? What if you will go to quiz? Oh, what were the quiz here? Quiz 1. Begin. And you will see. Okay. I will check, do you see or not? No, you don't see now. Review test. Now I will change my screen and you will see quiz. Review test. Share. Okay, you see now. What question 1? Choose the right relationship between linear momentum P mass m and velocity v. You remember definition P equal mass times v. So now, doesn't matter just now, is vectors or scalar. Let me focus, for example, let me think that here you see one-dimensional motion, so we have only one dimensional motion. So there is no understand, simplify this, but understand P and V like impulse in x direction and velocity in x direction. So if you know P equal m times V, which from this equation are correct? Just choose the right relationship between linear momentum P, mass m, and velocity V. Okay, I want to see your result with the first equation. Now I will go to duplicate. Full grade center. I go to full grade center and I will see how you start to work. Lecture 16, class quiz 1. And I see you started. Yes, good. How many students? 1, 2, 3, 4, 5, 6, 7 students are working. So what we see? Eight students. So how many students participate? 14 students participate in our session. 14. And only 7 students work with quizzes, with first quiz, first quiz. Why? What this is, what every time is it surprised me. Student, if you hear me, all of you which are on session, 14 students, 15 is me, with me. Total 15 people are in this session. 14 is the number of students. All 14 students now have to work with the quiz number 1 of this lecture. So you have to go to I will check again how many students still the same. One, two, three, 4, 5, 6, 7, 8. 8 students. 8 students participate in lecture 16, class quiz 1. So I will again repeat for all students what you have to do. In Blackboard, you work with the collaboration ultra. Before collaboration ultra, you see content. Go to content. In content, you see many first syllabus, part from syllabus, and then you see lecture 1, lecture 2, lecture 3. So today you have to go to lecture 16, linear momentum and collision, chapter 8 is the name of this folder. Do you see now? No, you don't see. Okay, I have to show you for all students. Share application screen, so content. Content? Now you see. For some reason, On the bottom, you see physics of music. Don't touch this. It's not for you. For you, you have to work today with lecture 16, linear momentum and collision, chapter 8. So you go to this lecture 16, and after first video, impulse and momentum, you see you have to find lecture 16 class quiz 1. And now we do first question. We answer the first question. If you will answer first question, try to answer second question, but start from first question. So what is first question? Okay, I will check again how many students we have now. Okay, I will check again. Full grade center. And I have, it's better, now better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Record. Okay, we lost 3 students. Okay, and now I will check your solutions. Correct solution or not correct solution, doesn't matter. I will use some random students, attempt, and what we see. Not given. Question 1. Question 1. Okay. Now what I will show you example of answer. Only don't use the same numbers. What in this answer, students? Okay, great test. You see already. You see question 1. You see this P equal MV. Because P equal MV, by this reason M equal P over V. And by the same reason V equal what? Therefore, student don't find all correct answer. His choice was only P equal MV, but because P equal MV, if you do algebra job, M equal P over V, or V equal P over M, or P equal M or P, no, P equal MV is the initial. So there is not one answer, correct answer. There is 3 correct answers. You have to do choice, not one. All correct answers. Okay, so what this student made not correctly. His choice only one correct answer, but there is 3 correct answers. So let's check another student. For example, another student. Okay. This good. 3, 7, 8. Dus M equal PV, V equal P over N, P equal MV. 3 correct answers. What? Good. Okay. We finish first question. Go to question 2. What is question 2? Okay, I will check an example of this student. Question 2. What? Already in question 2, we have F mass, time delta t, and velocities, final and initial. So we have to work with the next formula, what we saw in this video. No, really, we saw in form F times delta t equal mass times V final minus mass times V initial. But if you will work with the algebra job, so for algebra job, give you what more than two correct relationship which exist in this list of like relationships. So delta t why? One moment. I don't like this. Why delta t? F delta t equals this. So mv final minus mv initial divided by f equal delta t, or f equal mv final minus mv initial divided by delta t. Yeah, 4, 5, 8. So student made correctly. So you see, again, there is a 3 correct choices, and student made this choice correct, made this choice correctly. Okay, what? Question number 2. Okay, I will not show question number 3. Try by yourself. So you know now correct answer to question number 1, correct answer to question number 2. Now we think about correct answer to question number 3. I will not show you. Okay, how many students working now? I have to check. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11 students. 11 students. Very bad. Very bad. Because we have on session, we have 15 students. Where are 4 students? I don't know. Okay, students. So you continue to work with this quiz 1. Really, first video is enough to continue. No, but yeah, I will already run next video. It's a little bit more one step to understand what's the relationship between momentum, impulse, and how to work with this with different problems. So let's go to next video. Elastic and inelastic collisions. So we will apply, now you will see how apply law of momentum conservation for special collision of 2 objects, maybe 3 objects, elastic and inelastic. What does it mean, elastic and inelastic collisions? Okay. Okay, from beginning.
Hey, it's Professor Dave. Let's learn about collisions.
He knows a lot about the science stuff. Professor Dave explains.
Whenever an object in motion comes into contact with another object, we can call this event a collision. And this concept applies to balls on a pool table just as it does to tiny molecules or huge celestial objects like asteroids and planets. As we just learned, in any collision there must be a conservation of linear momentum, but this can manifest itself in different ways depending on the type of collision that is occurring. So let's go over these varieties now. First, we will discuss elastic collisions. These resemble collisions between balls on a pool table, where the objects involved remain separate after the collision occurs. With elastic collisions, total kinetic energy will be conserved, as well as the total momentum of the system, so the objects will bounce off of one another with no energy lost whatsoever as a result of the collision. We approximate collisions between atoms and molecules as being elastic when we refer to an ideal gas, just the way we do with billiard balls. There are many other examples of collisions that aren't completely elastic, but we can treat them that way, like when a soccer player kicks a ball, since the player's foot and the ball do indeed remain completely separate after the collision. We would refer to all of these scenarios as examples of nearly elastic collisions, since some kinetic energy is lost to heat and sound in each case. Perfectly inelastic collisions are those in which two separate objects collide, after which they move together as one mass. Sometimes when celestial bodies collide, like two asteroids, the collision is inelastic and they fuse together to form a larger body. In fact, this is how all planets begin to form, including the Earth, over the course of millions of such collisions. When we examine perfectly inelastic collisions, it is easy to analyze momentum because we can treat the two objects as a single object after the collision, with a momentum equal to the sum of the two individual momenta. This is illustrated by the following expression, where m1v1 plus m2v2 is equal to the sum of the masses times v final, which will depend on the magnitudes and directions of the two initial velocities. This approach can also be used to model car collisions, whether the two cars were moving in the same direction or opposite directions. Adding the masses of the cars and combining the velocity vectors will tell us what will happen after the collision. We should note that during inelastic collisions like car crashes, total momentum is conserved, but total kinetic energy is not conserved. Much of the kinetic energy is converted into sound energy, which we hear as the sound of the crash, as well as heat energy and the internal energy of the new system, which allows the bodies to deform as a result of the collision. That's why we call it an inelastic collision. An elastic band always returns to its original condition after being stretched. But with an inelastic collision, things are very different before and after the collision. The amount of kinetic energy lost during an inelastic collision will depend largely on what the objects are and a variety of other factors. In reality, no collision is completely elastic or perfectly inelastic, but is somewhere in between, which we can simply label inelastic, implying that some kinetic energy is lost due to the collision, even if just a little bit. But we can usually approximate a collision as being one of the two extremes, which will simplify the math that must be done in order to make predictions about systems that end up being extremely accurate. This concludes our study of linear motion, which from kinematics and dynamics to harmonic motion and momentum has been quite extensive. But before we move on to circular motion, let's check comprehension.
Okay. Start this. Okay. So given data, we know mass of first car and speed of first car. And we have mass of second car and speed of second car. And we know about direction of velocity of second car is the opposite of velocity of first car. You see it moving opposite direction. What in a head-on crash. You see it's the same axis but opposite direction. So then we made decision that we have to use in like this process and understand like inelastic collisions. Inelastic. Question: what will be speed after collision? So we have to write equation. Initial impulse, we write like the direct formula m1 v1 plus m2 v2 is the impulse before collision equal after collision, because we have inelastic collisions, means these two objects, these two cars already move like together. So they have the same velocity. So we can write total mass equal m1 plus m2 times velocity final is a final momentum. So initial momentum, который equal final momentum, we have to find velocity final. We do substitution and focus. Why we have minus 15 meters per second, not 15? Because we read is the opposite direction, opposite to first car. So minus 15 meters per second. 20 plus meter per second, minus 15 meters per second is the opposite direction, by this is on minus. Not. And from this equation, we can find velocity final. And we are happy that velocity final is positive, but it can be negative too. It means pushing of car we go to opposite direction is the greatest, and pushing of car we go to positive direction. But student, be careful. If question about magnitude of velocity, so magnitude is every time it's a positive number. So if question about velocity for linear motion, it go to right, positive, go to left, negative. Question about velocity for linear motion in one direction. But question is not about linear, not about velocity, a question about magnitude of velocity. It means your answer have to only positive, because magnitude is mean absolute value. Okay, so we know second some idea, but we know first term. Main term is a inelastic collision. I'm going to say absolute inelastic collision. And you know what does it mean? It means after collision, two objects, many objects collide, move together like one body. And elastic collision. Elastic collision, main characteristic, kinetic energy, total kinetic energy doesn't change. How to use this in equation, in solution is another question. But main idea, we have for elastic collision not only law of momentum conservation, but we have law of, no, I don't know if we can call this law or not, but we have a kinetic energy conservation. Initial kinetic energy of all system equal final kinetic energy of all system. Okay, student, so let me check now how we work. Go back to test. Now I will check how go your test. What is your results? And I will focus to some students' results, some random students. And I will show you. So we finish problem 1 and question 1 and question 2. Now I have to focus to question 3. So now I will do choice of some random student, and let me check. This question is good or not good? Okay. So I go to grade center and I use.
Can you share the screen?
Excuse me. No, yeah, I will show screen when I will show when I will prepare. I will show screen. So I will okay, some random. I will make choice of some random student, and now I will change screen. Okay, change screen. Okay. So what we see? So it's question 1, student made correctly. He found 3 correct answers, the 3 correct relationship between M, P, and V. Question 2, again, student made correct relationship, find correct relationship between F, time, mass, and velocity is final initial. Yeah. Question 3. What? In question 3, already perfectly inelastic collision in one-dimensional motion. Mass M1 moving at the speed v1 collides with a mass M2 moving at the speed v2. The collision is completely inelastic. It means after collision, 2 masses move together like one mass. Velocity after collision is velocity final. So we have to find again correct relationship between all these parameters. No? If we will focus to initial equation, what we see is what in this solution is equation number 8. M1 plus M2 times V final is a final momentum, and you see these 2 objects, they move like one body with a velocity V final. This is a M1 plus M2 times V final is a final momentum, and M1 times V1 plus M2 times V2 is a initial momentum. So we see in equation 8, in formula 8, final momentum equal initial momentum is a condition for any collision. But from equation number 8, we can derive equation which can find velocity final or initial momentum for first object. So there is not only one correct answer, there is a 3 correct selected answer with correct relationship between all these parameters. So what question 3 is, you see correct answer. Okay, question 4. What in question 4 you have to calculate already. So you have to show that you can work not only with the algebra transformation of physics formulas, but you can really calculate. So question 4. You know P equal M times V is the main equation, give definition of momentum. And you know mass, we know magnitude of velocity. Question, what is magnitude of momentum? No, it's easy to understand how to calculate P, exactly M times V. So we do M times V, and we have answer, and student find correct answer. Yes, question 4. Question 5, no, the same equation, only now given V and P. And again, let's focus magnitudes. Just in case I write magnitude, but in any case, if we have only one object, they work in the same direction. No, so just in case I use magnitude, V and P. No, and so M equal what? P over V. Yes. So and student found correct answer. Question 6. No, the same equation, only now unknown is a velocity. No, magnitude of velocity. So it means speed. We don't focus to direction. Magnitude of velocity. And you see it is what velocity? Velocity equal P over M. So, and you see student find correct answer. Student, be careful. Your numbers are different. Don't use this answer like your answer for your questions. Because in your question you have another numbers. No, question 7 not given. Okay. Okay, I give you time to write correct answers for first 6 questions, and then we will discuss question 7. to this student. What? No, maybe you understand it's yours. What? Think about question 7. Now it's not given. So another which didn't finish previous question, 6 question, focus to your 6 questions. So now I will check. No, if I will see, I will check more random students. Okay, no, for example, I don't know. Okay, I will check now some students. Okay. What now? I will check this student.
Professor,
Okay.
which attempt we are working on? I just joined class right now.
No, work. We're working on questions. Now we work on first 6 questions. When you finish 6 questions, think about seventh question. What? Now what I see, what more one student. Now I will explain his mistake. You see the answers of the students. What a mistake. Okay, what a mistakes. Question 1. In question 1, we have 3 correct choices. If P equal M times V, so V equal P over M or M equal P over V. 3 incorrect answers. In question 2, F delta T equal MV final minus MV initial is correct. But there is more one correct answers, but student made not good choice. If F delta T equal MV final minus MV initial, it can be correct F dt equal MV initial minus MV final. Focus I and F. I is the initial, V final. Correct is a from final minus initial. No, and of course, if F delta T equal MV final minus MV initial, so delta T cannot be MF final minus MF initial times F. According to our algebra knowledge, delta T is MV final minus MV initial, total in parentheses, divided by force. And force equal, again in parentheses, MV final minus MV initial, total divided by delta T. So student, who is a student? You have to learn algebra. In physics, we have to apply algebra. And your course is an algebra base. Doesn't mean no math base. You don't, it's not calculus base, of course. Because you don't know what does mean integration, differentiation. But you have to know simple algebra, transformation. Simple algebra transformation. You have to apply. Question 3. Question 3, no again. What? All choices are not good. First, you have to do main choice by definition. What? If we have what kind of collision? The collision is completely inelastic. So, by this reason, only because of this reason, correct answer is answer number, what in this number 7. То есть total mass times velocity final equal first momentum m1 v1 plus momentum of second body m2 times v2. What? Number 7. No, and from the 7 we can, using some algebra job, we can find, if you want to find m1 v1, what will be formula, and if you want to find velocity final, what will be formula. So just now 1, 7, and 8 equation give correct relationship between all these parameters. But basic equation is equation number 7. Another we derived from equation number 7. Why student made this solution? I don't know. This student don't know algebra. Question 4 not given. Calculate student, it have to be easy. If you know m and v, how to calculate p? Do multiplication. Question 5 again not given. What do you do, student? Do calculation. If you know v and p in previous formula p equal mv, we can find m equal p over v. Very easy. Do calculation. And question number 6. Again, easy formula. If you know v and p, if you know m and p, how to find v? Of course, p divided by m. Do calculation. I don't know why I don't give it. Okay, not good. This student working not good. Okay, let's found someone. No, now we are ready, I hope. Okay. Now I will check some another student. Now I will focus to problem number 7, question number 7. So, and I will check solution of some students. For example, which student? Okay, this student. Okay. And you see, yes. You see what I do. You see what I do. Question 1 correct, question 2 correct, question 3 correct, question 4 correct, question 5 no, very close to correct. I don't know why.
I just rounded up for that one, Professor.
I don't know why not exactly. This question 6 correct. Now question 7. Interesting. Very close, but not exactly. Why? I don't know. Okay, let's what. Now I will try to explain question number 7. So what really we have this mass m1 kilogram moves in the direction of x-axis with the speed. So we know mass 1, we know speed 1. And mass m2 move in the direction of the y-axis with the speed v2. So what is the magnitude of the total momentum of these two masses in kilogram meter per second? Input the numerical part of your answer using 3 significant figures. Okay, so first I will focus. What are direction of these masses? And we see the speed direction of the x-axis for mass m1 and direction of the y-axis with speed v2. What, student, is very important. X-axis one speed and y-axis another speed. So if we have two vectors, one vector have direction to x-axis, another vector have direction to y-axis, this means angle between these two directions is 90 degrees. How to do summation of these two vectors? And you have to know, we have to use, if 90 degree, Pythagoras theorem. So first momentum squared plus second momentum squared and root squared from this. Okay, now I will teach you how to use, I don't know, Google search. Google search. I will show you how to use Google search for this, to find solution of this problem. So first I highlight this program. Then I will go to Google search. Okay, Google.com. So now I will show what I will do in Google search. I have to change my screen. So Google share. So you see my Google search page. Yeah, you see. So this in Google search, first I paste all data. And now, because I don't remember numbers. And now I will, from this data, I will write equation. So mass 1 times V1 squared, because total squared, because it has to, I have to use Pythagoras theorem. So, okay, I will start. What? M1 is a 761 kilogram times P2, 4.06 meter per second. And what I erase, I will not erase units. First is a kilogram, second is a meter per second. Okay, what? This is what I made first momentum. 7.661 kilogram times 4.06 meter per second is the first momentum of one body which have direction to x-axis. So squared. I will use Pythagoras theorem. Okay, second, 638 kilogram times speed v2, 4.56 meter per second. This is a second momentum squared. So I don't need more numbers. I delete all these numbers. So what I have to do first, because I have to use Pythagoras theorem, square of first momentum plus square of second momentum. I have to take root square from this. In many languages, computer languages, square mean SQRT. So I will write SQRT and parentheses open and parentheses close. So what? This is my formula. Okay, you see my formula. This SQRT is mean root squared, first momentum squared plus second momentum squared. I click enter after this, and I see some number, and you see this unit, meter kilogram over second, 42.4. Now I have to focus what is really equation of this problem. Have I to give answer in scientific notation or not? So I go to problem and I read, input the numerical part of your answer using 3 significant figures. Only one condition, 3 significant figures. So because I have 42.43, just after what 3 single figures, 4, 2, 4, next 3, because less than 5, I don't need to change last 4, so my answer has to be 42.4. 42.4. And what is the answer, correct answer? 42.4. What? Why these students have 43.1? Close the number, but not exactly. I don't know. No, I have guessed maybe because he used calculator. Student, I teach you, don't use calculator, simple calculator. I push you to use good systems like Google search or like Google Sheets. Okay? Because you will do mistake like this. Maybe small mistake, but it's not good. They're not good. Okay. No, because I have time, I want to teach you how to do the same problem using Google Sheets. Now you use Google Search, now Google Sheets. That's why no, you have to know how to use both methods. What? Okay, so now I will open Google Sheets. You know how to work with the Google Sheet, I hope. So I will Google Sheets. The same problem. I go to Google Sheets. Okay. Mhm. Okay, so now I will change my screen to Google Sheets. So I will go from this and I will go to spreadsheet now and untitled spreadsheet. What? You see table like this, Okay, first I have to copy and paste text of this problem, no? Because I don't remember the numbers. Let me check. I have or not? Yes, I have. What? So, and to better understand my given data, I will write number separately in separate cells, but I will mark what kind of cell to this. Close to this will be M1 in kilogram. Of course, when we will do faster, no, maybe we will not write every time in kilogram or meter per second, but now I will write V1 is in meter per second, What and what is the M1? So now I will already write data. Oh, this is for M1. This is for V1. V1, then M2. No, okay. Okay, I can write like this. M2 in kilogram, then V2 in kilogram, or in meter per second. See what now I show units, but in cell I write only numbers. So because Google Sheets cannot work with the units like Google Search. So M2 I write number, and I write number for V2. Okay. No, and P total, P momentum total. I will calculate this. So formula equal this. Any calculation in Google Sheets start from sign equal. Then formula is the same. Root squared from first momentum squared plus second momentum squared. Pythagorean theorem. So root squared SQRT, parenthesis open. First momentum. No, to repeat many times the same worksheet for different number, now in equation I will not use numbers, given numbers. I will show where these numbers are located, in which cells. So M1 located in cell B3. So I will put B3 times B4 is velocity, and this has to be squared. So I have to use parentheses and this squared. So you see how I write squared in Google Sheets. The special sign, this will look like roof of home is mean power, and power 2 plus, again parentheses, now M2 times V2 is a second momentum, again squared, and parentheses for SQRT finish it. So you see equation, SQRT, parenthesis open, B3 times B4, parenthesis close, squared, plus parenthesis open B5 times B6, parenthesis close, squared, and total parenthesis close. Enter, and I have the same number. Because 3 significant figures, now I can use properties of Google Sheets to decrease number of significant figures to 3. So by this reason I have on the bottom special decrease decimal places. So I click many times to have only 3 significant figures, and I have answers 42.2, 42.4. What? If you will read in problem, in last sentence, input your number using scientific notation, your next step will be go to format, number scientific, and you will see scientific notation 4.4 with 4.24 E plus 1. Why plus 1? Because our decimal point jumped to left one time to stay after first not 0. Okay, students, so no, if you want to see exactly this my to see this my Google Sheets, I will share with you. So how I will share? I will do this. First I give name, problem, some problem. Okay, and I give you chance to anyone with viewer, commenter. So copy link. Now I will submit link to this Google worksheet. I will do this where? I will do in Okay, everyone. What you see, link now. I submit link. If you will click, you will reach this Google Sheet. I hope it will work. Check, student. So some example how, and now you can, if you will copy and paste this Google Sheet, like your Google Sheet, you can calculate answer of this problem using your data. Only have to change data to your data, that's all. Okay. No. We will check next video. I think we will go back to your problems if you have time. What is our video? So we finish this video. Next video already. Okay, we have two videos of Professor Dave. Now, not Professor Dave, a short video, an example problem involving momentum conservation. Watch video. So I will watch video this. Now I have
between a
from beginning.
In the most recent video, this one, I ended with a problem. I showed you the answers and promised you a video guided solution. If you need to review this video, you can look in the description section for the link. Otherwise, continue playing and see the solution to the problem. In this problem, I have a collision between a red cart and a blue cart, and they're moving opposite directions, one east and the other west. So I'm going to say east is the positive direction, west would be negative. As I solve the problem, I begin with a diagram. I show my two objects before the collision and after the collision, and I list next to my objects values of mass and velocity. There you see it listed. You'll notice that for the blue cart before the collision, the velocity is negative 50 because it's moving west. After the collision, the velocity of the blue cart is positive 70 because it's moving west. For after the collision, I don't know the velocity of the red cart, so I'll just call it V, or V1 prime, where the prime symbol indicates an after the collision velocity of object 1. I then draw a momentum table, and in the table I'm going to put the momentum of red cart, blue cart, and of the system. For the red cart, it's mass times velocity, 1.5 times 30, and that comes out to be 45 units of momentum. For the blue cart, it ends up being 0.5 times negative 50. That comes out to be negative 25. I have to add these momentum values up to get the total. So positive 45 plus negative 20 gives me a total momentum of 20 units of momentum. That's in the bottom row. If that's what it is before the collision, that's what it is after the collision as well. So the momentum of the red cart plus the blue cart after the collision has to sum to this total of 20. For the red cart, I don't know its velocity, so for its momentum, I'm going to go mass times velocity. That's 1.5 times V. I'm looking to solve for V. And for the blue cart, I go mass of 0.5 times velocity of positive 70. That's 35 units of momentum for the blue cart. And what I know is that 1.50 V, whatever V is, plus the 35 is equal to the 20. So now I have an algebra problem, and I have to solve for the value of V. I do my algebra by getting the V term by itself on one side of the equation. That means I have to subtract 35 from both sides. The equation becomes 1.5V equal 20 minus 35, or negative 15. Now I divide through by 1.5 to get V by itself. That's negative 15 divided by 1.5. On my calculator, that comes out to be negative 10. The unit here is centimeters per second. So the velocity of the red cart after the collision is negative 10 centimeters per second. So the speed is 10 centimeters per second, and the direction is west.
Okay, student, what you see? What is important
in the most recent video?
In this video,
you can look in the description. So I'm going to say
what? First, we have to focus to direction, to better write equations. And what we see, one car moving to east, another to west. So east-west mean the same axis, but one car have moved to one direction, another to opposite direction. So first we have to do choice. What is the positive direction? No, let we make choice. Is the positive direction. So after this, we have to write equation. And what we know is in equation? We know all initial data, velocities and masses before collision. After collision, we know masses because masses doesn't change, but we have only one velocity. Now, if you will write equation, you will find that another velocity we can understand like unknown, but we have to find. And what this professor show you, one method, maybe I don't like this method, but he show how to find unknown, using some calculation. Some example. Let me check some another example. This video. Let me check another video. Okay, what is the next video? Professor Dave now will show us another practice problem for inelastic collision. No, my guess it will be similar, but just in case we will watch next video too.
He knows a lot about the science stuff. Professor Dave explains.
You and your friend decide to spend the afternoon at the ice skating rink. But to mix things up, you decide to bring a 0.2 kilogram frisbee. Much to the irritation of the other patrons at the rink, you begin to toss the frisbee back and forth as you skate around. Given that you are both really into physics right now, you try an experiment. You stand perfectly still while your friend tosses you the frisbee as hard as they can, which turns out to be 20 meters per second. When you catch the frisbee, assuming the ice is frictionless, you and your 70 kilograms of mass are propelled backwards. But with what velocity? To figure this out, we just need equations regarding collisions, since we can consider catching a frisbee a collision of sorts. Check out my tutorial on this subject if you need to, and then see what you come up with.
Okay, so what we see, given data, what is a red object, we know velocity and we know mass, initial velocity and initial mass. For this guy, blue guy, we know mass and we know initial velocity too. Initial velocity equals 0. Now we think, what will be collision? Because it catch this red, I don't know how to call this, red. They will move together, like one object. Because they will move together, it means we have absolute inelastic collision. So after collision, like total mass will be equal mass of this guy plus mass of this red object. So we have to find velocity. Now we will see solution.
As we said, when you catch the frisbee, we can regard this as a collision, and more specifically, an inelastic collision, as the frisbee doesn't bounce off of you, but rather you and the frisbee become one object moving together. The equation regarding inelastic collisions tells us that m1v1 plus m2v2 equals the quantity m1 plus m2 times v final. So let's just plug in everything we know. Taking u to be object 1, your initial velocity was 0, so we can just get rid of this term. The Frisbee has a mass of 0.2 kilograms and was moving at a speed of 20 meters per second. Then over here, we can add the two masses to get 70.2 kilograms and then solve for the final velocity. That will give us 0.057 meters per second. This is pretty small, of course, given the huge difference in mass between you and the Frisbee, but it's still a pretty interesting way to get across the ice. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can...
Okay, students, now I will focus to problem number 8. Problem number 8, and I will choose of some student, random student, no, maybe not random student, okay, not given. Question 8, to start, okay, question 8, what, now I have to change my screen to show you. Okay, question 8. And you see, the student didn't find correct answer. His answer is wrong. Let me try to understand what happened. Why? Let me read. We have mass 1 move in direction of the x-axis with the speed v1. And mass m2 move in the direction of the x-axis with the same x-axis with the speed v2. What's the magnitude of the total momentum of these two masses? So first object moves to direction of x-axis and second direction of x-axis. So if the same direction, the same component, how can add two momentum, two vectors, if they have the same direction? Only simple addition. So, okay, now I show you what have to be answered. I go to Google search. Okay, now I can just change my screen to show now Google search. Okay, where's search? This is search. Okay, so I paste data, Google search, and what I will do, mass M1 in kilogram times V1 in meter per second to x direction, plus, because the same direction, mass 2 in kilogram times V2 in meter per second. No root squared, nothing. There is no Pythagoras theorem because the same direction. Okay. And I don't need more anything. So first mass times first velocity plus second mass times second velocity. I forgot to put sign times. Oh. Enter. And what my answer? 72 point, because after 1 we see 9, it have to be 72.2. What is the answer? Exactly correct answer, exactly 72.2. So be careful, student. Again, focus to direction. Because most important, not to calculation, to understand how to calculate. This question number 8. Okay, student, let's go to question number 9. Question number 9. And again, focus. What is different between question number 8 and question number 9? And you see, student again made not correct answer. Okay, you don't see it just now. You don't see, I have to change screen. Okay. But now you see, question 9, and student didn't find correct answer. Let me read. Mass M1 again, velocity V1 again, mass M2 again, but focus in the opposite direction of the x-axis. Only one word, but this one word change our calculation because opposite direction of x-axis with the speed. So velocity V2 is a negative, not positive. So what we have to do? Okay, I copy this, and again I go to Google search. I go to Google search. Now I paste data, and I take only numbers with units. First mass times speed, first speed, meter per second, but mass 2 times, don't forget to put times is a star. This mass 2 times speed 2, I have to subtract from first. I have to put sign minus, y minus, because I read opposite direction. So I don't need more. So I have mass 1 times speed 1 minus mass 2 times speed 2, y minus, because opposite direction, enter to calculate. And I have number minus point, just minus 1.32. Because after 2 we have 5, we have to change 2 by 3. So we have minus 1.33. What is this? This is a velocity. So this number gives us direction. Direction is a opposite to x-axis. But let me focus again to problem. What is the question? Question about magnitude. A question is about magnitude. We don't need to focus minus or plus. We have to give answer only like positive numbers. So our answer have to be 1.33. 1.33. Exactly what we see in correct answers, 1.33. So I give you proof. So where is the answers? Answers is, okay, I will change this. But now you see selected answer. I don't know how calculate student. My guess, he didn't focus to work opposite, to word opposite, and he used plus, but necessary to use minus. And we have this answer 1.33. 1.33, of course, correct answer 1.33 kilogram times meter over second, but by condition of this problem, we have to input only numerical part, 1.33. Okay, let student focus to problem 10. Okay, but now this student didn't give answer. Okay, student, try to do question 10. I will read what, no, we don't see now answer. Okay, maybe student already made this answer. I will review. Yeah, no, didn't give. Okay, question 10. What is average force exerted on the some number of kilogram object drink and impact, assuming that the object speed just after impact is 1.6 meter per second, that the initial horizontal component of the velocity before impact is negligible, okay, and that the object remained in contact with impacting item for 1 millisecond. Okay, what question 10 is what are given data. First, we know mass of object. And okay, what's it? So we know object speed after impact, and we know initial horizontal component velocity before impact is negligible. We know horizontal is negligible. We don't focus to horizontal speed, but we know, and then the object remained in contact with impact item for 1.5 millisecond. So we know time, we know mass, we know velocity, no speed after impact. Our guess, what will impose velocity before impact? 0. So what kind of equation we have to use? We have to use equation F times delta t equal change of momentum. A change of momentum is mass times change of velocity. This mass times change of velocity equal force times delta time. We know delta times. So because we know delta time, we can find force, average force. This average force equal mass times change of velocity divided by time, change of time, delta t. So I will calculate for this student, I will calculate what result. So you remember what you have to do. Change of momentum divided by time of impact. It will be force. So I copy this, go to Google search. I will use now Google search. Paste. Okay, I have to change screen. So I paste problem with the data, have data, and I delete what I don't need, words. So I have mass, kilogram. I don't need PHYS. This mass times change of speed. From 0 to this, it means it is exactly change of speed, and divide to time. 155 millisecond. Millisecond. No, what? I might guess ms will be enough. I will check. Enough or not? Or maybe we can write okay, I will keep millisecond. What will be? Millisecond. Okay, so you see mass times change of velocity, velocity divided by time. What is the answer? And give me answer. 58.07 and so on Newton. So my answer have to be after, because I have to use only 3 significant figures, 58.1 n Newton. So I have to input 58.1. Let me check. 58.1, yes, is correct. So problem number. So I will go back. I will show you. I will give proof that my answer is correct. You see, 58.1. 58.1 is answer. No student, any questions? Now we will finish official part of our session. So you have to continue work with this quiz, class quiz. Maybe I will give you homework. I don't know, but I have some preparation for homework. So before you will finish our class, our session, any questions, but you have to know I will stay after your question to work like in office hour to any student who want to work with me. Okay, questions? What? No questions. No, my question. 1, 2, 3, 4, 5. No, I have now 13 students. And I see in my grade exit how many student works. Lecture 16, class quiz 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13. Okay. I saw some question. Can you check my work, please, professor? Check my work. Okay. You are Rachel Altman. Okay. Yes, Rachel Altman. Now we see your work. Rachel Altman. Okay. Altman. Okay, I see Rachel Altman. And now lecture 16 class quiz 1. Attempt. So now I have to check. Do you see? Yes, you see. First question correct. Second question correct. Question 3 correct. Question 4 correct. Question 5 correct. Question 6 correct. Question 7 correct. Question 9, not correct. Why? I don't know. My guess, mass M2 move in the direction of the mass M1, move in the direction of the x-axis with speed, and mass M2 moves in the direction of the x-axis. It's very easy formula. M1 times V1 plus M2 times V2, because they move to the same direction. So you use not correct formula. Question number 9 is correct, opposite direction. Question number 10 is not correct. 10 not correct. Question 11 not correct. Question 12 not given. 13 not given. 14 not given. 15 not given. 16 not given. Okay, you know. Try or ask me to help but first try by yourself. You try to find your mistake. Then if you will not find, I will help you. I will calculate for you. Okay, another student. So now is the 7:46. Officially, I give you permission to leave session. But if you want to work with me, use this. Use my knowledge to help you. It's better than use some pay for tutor. Nesser, let me check yours. Yes? Answers. Before you finish. Yes. No, we will check. You need more 5 minutes. Okay, okay. After 5 minutes, I will check. We will check yours. Five minutes. Yeah. Okay, do this.
Professor, how do we do question 13?
13.
Yeah.
Okay. 13. 1, 3, yes? Okay, perfectly inelastic collision. In one-dimensional motion. Okay, it is inelastic collision in one-dimensional motion. Inelastic. То есть we know mass m moving with speed v1. Collide with a mass km. What does it mean km? It means k times m. То есть k times greater than mass m. Moving at speed v2. The collision is completely inelastic. Velocity after collision is v final. So what we know? We know K, we know V1, we know V2, we know V final. Oh, I really don't understand what. No, and
What's the formula?
formula is what M times V1 plus K times no, we don't know M. Okay, understand what we don't no no, one moment. Okay, mass Km at the speed V2. Different collision is one dimension motion. Okay, completely inelastic. Okay, what to find solution? We have to write first equation. Okay, maybe better to show this equation using. Okay, I will write formulas. But where is my? One moment. I don't see my. Okay, if I will turn on whiteboard. Okay. Okay, I will try to by words and I will write. So what? This equation M times V1 plus Km times V2 equal M plus Km total mass times V final. So what is V final? V final equal MV1 plus Km V2 divided by M plus Km. But we don't know M, yes? Now we have to do a little bit algebra job. What? So we have ratio. On the top, MV1 plus KMV2, we can write like M times V1 plus KV2. V1 plus KV2 is parentheses. On the bottom, we can write M plus Km. We can rewrite like M times parentheses 1 plus K. And after this, M cancel it. And we have ratio V1 plus KV2 divided by 1 plus K at the bottom. Now I will try to find my whiteboard. I don't see where to. Okay, maybe I will use this. One moment. Okay, what to give to this? Go to this. Share a blank. Okay. If my screen working, what? No, don't work. No. Yeah. M V1 plus Km V2 equal M plus Km times V final. But you have to solve this for V final. So V final equal ratio on the top mv1 plus km v2. On the bottom, total mass m plus km. And you see, m on the bottom and m on the top can cancel it. So if m cancels, we have this one. So we have v1 plus kv2 divided by 1 plus k. Do you understand?
Wait, you said 1 plus k?
1 plus k on the bottom, yes. Because we have m plus km. If we m cancels, we will have 1 plus k.
Okay.
1 plus k. Okay, student, I am here. Who want? Can you check my work? Okay, Montana, now we will check your work. Montana, you are here. Okay, Montana, yes, you're here. So we go to Montana. Okay, who is this? This is Montana. Renew. We will check your answers. Okay. First correct. 2 correct. 3 correct. 4 correct, 5 correct, 6 correct, 7 correct, 8 correct, 9 correct, 10 correct, 11 no, first, what not correct? 3 significant figures have to be. You have 2 significant figures. 6, 8, only 2. We don't count first 0. 6, 8. Maybe already by this reason system will not accept. And your answer is close to my answer. 6, 6, 1, 6, 8, close. Not exactly. No? I don't know really how a system will accept this or not accept, but so better correct your answer. What? 661, 0.0661, 3 significant figures, because we don't count first 0, we don't count next 0, we start to count from 6. So 661, 3 significant figures. Okay, question 12 correct. Question 13 correct. Question 14 correct. Question 15 not correct. Close but not correct. I don't know why effect in a collision in one direction motion, mass and volume moving at speed v1, collect moving at speed v2. The collision is completely inelastic. Velocity after collision is vf. So you have to find v1. v1. Ну, то есть we know v5 and what? In collision in one-dimensional motion, mass m1 moving with the speed v1, collision the mass m2 moving with the speed v2. To see how to do this? Very easy. I don't know why. Do you need explanation? What do you think? Why you have different? It's a mistake in calculation or what? Montana. I can explain formulas. Okay, your answers. Can you check my work? Still isn't difficult, but please. Okay, no. Okay, what? How to do what? How do this problem according to my experience? What I like. So again, I have to read your question. Okay, so it's what we know. So we know M1 V1. So M1 V1 plus M2 V2 equal M1 V final plus M2 V final, and we can find V1. Okay, now I will work with the whiteboard. M1 V1 plus M2 V2 equal M1 plus M2 velocity final equation. What is unknown? V1. So, next step. M1 V1 equal formula M1 plus M2 times V final minus M2 V2. And after this V1 equal, so we have to divide left and right part by M1. So we have M1 divided by M1, 1 plus M2 over M1 V final minus M2 over M1 V2. This equation is V1 equal 1 plus M2 over M1 V final minus M1 over M2, this M2 over M1 times V2. No, now I will try to calculate. So I will take U data. Okay, now I will use to show you, I will use Google Sheets. Okay, Google Sheets. So I go to Google Sheets. Okay, I have already. So I will change screen to Google Sheets. I have already one problem, so now another problem. First I will paste. Okay, so I have data M1 V1, M2 V2. So no, only I have to write this to do calculation. I have to write separately without units and names. So I have to calculate V1. I have M2 V1. Okay, can you check my work? Don't use calculator. Don't use calculator. I teach students use modern methods. Modern methods. What? I write number separately. You see this? Yes, you see this. Check. Yes, you see this. And now I will write formula for V1. So V1 equal, so because I use calculation, start from sign equal parentheses 1 plus ratio M2 is this, divided by M1 is this. See? When I write equation in formula, in code what I write, I don't use numbers, I use name of cell where number is located, times velocity final is this, minus again M2 over M1, M2, no, only what, okay, I will finish them, over M1 times V2. But first time it will not calculate me because I forget to delete kilogram in numbers. Okay, now I enter. Oh, I have number 11.57. 3 significant figures. Okay. So I do like this, and I have 11.6. What is correct answer? Correct answer is 11.6. What? No, I will increase you. If you don't see this, if you see not very good, so I can increase screen. Now you see screen. То есть what? What is formula? You see, I write formula this. То есть 1 plus M2 over M1 times V final minus again M2 over M1 times V2. But in my code, I use not numbers, I use name of cell where these numbers are located. What? Numbers located. And if you made this 1 times for this problem, already if you will do this problem again with another data, you have already calculator to calculate answer. Only change numbers to another numbers, for example 5. Okay, and it will change. It will change automatically result because code is the same. Okay, Montana, do you understand? Okay, let's continue. We didn't finish. Yes.
Can you check mine now, Professor?
Okay, so first we will finish. We will go back to. Okay, we'll have to go back to. Okay, share application screen. We have to go back to grade test share. Okay, so we made this for Montana. Now question 16. Very close, but not exactly. Maybe reason you use calculator. You don't use my methods to calculate. Okay, and next student who want to check, who next students?
Miyuchi.
Let me check. Okay. Chan-Chi, yes, Chan-Chi, okay.
Yeah, thanks.
Chan-Chi, now I will see yours. Exit. Chan-Chi, okay. This is yours. So you now see, yes, you see your result. And we go down. First correct, second correct, 3 correct, 4 correct, 5 correct, 6 correct, 7 correct, 8 correct, 9 correct, 10 correct, 11 not correct. 11 not correct. The collision is completely inelastic. I don't know why. I think it's an easy problem. Standard problem. Standard formula. 12 not correct. What? No, maybe what I can have guessed why you don't. What in question 12, you have to use Pythagoras theorem. The result is a root squared from M1.
Wait, what?
In question 12, you have to use Pythagorean theorem to find total. Because M1 V1 have direction X, M2 V2 have direction Y.
Oh, okay.
So you have M1 V1 total squared plus M2 times V2 total squared and root squared from all of this. No, Pythagorean theorem.
Okay.
This question 13 not correct. Why not correct?
I used the formula you showed, which was the V1 plus V2 over K, 1 plus K. That's what I got.
No, okay. What? No, something is wrong. So, no, again, I will repeat what V1 plus K V2 divided by 1 plus K. Okay, I will calculate. So you have these numbers. V final. So I will go to sheets. Okay. So now I will show you what I will do in Google Sheets. Okay. So screen problem, Google Sheets. Now you see Google Sheets. You see K, V1, V2, VF. So I will write now a number separately without anything. So we have K, we have V1. So Google Sheet don't understand units. I will delete units. V2. Maybe you forgot in V2 sign minus.
No, I definitely put minus.
V final. Okay, what form of a V final? Equal. Okay. Parentheses. V1 plus K times V2, parentheses close, divided by 1 plus K. Enter.
Oh, you're multiplying the top by K? Okay.
Minus 1.4. What is the correct answer? Minus 4.13. You see?
Yeah.
What is
I
the
didn't
formula?
know you had to multiply the top by K. I thought it was just V1 plus V2.
Okay. So this is, let me go back. Okay, it's yours. Question 14, again not correct.
Yeah, that was probably the same
But
formula.
see, idea is the same.
Yeah, no, I just got to use the formula.
Now you have to solve for K. You have to solve for K.
Okay.
15 correct. 16 not correct. Why 16 not correct? Mass M1 moving speed V1 collide with the mass M2 moving speed V2. The collision is completely inelastic. Velocity after collision is V final. Have M1. No. Do you need help, or you can do by yourself?
No, I can do it now.
Okay. As you see, you made mistake. Do carefully. That's all, my guess. You made some mistake.
All right.
Okay.
Thank you.
You're welcome. No. Okay. Is somebody more?
Can you check my result?
Okay. You are. Who are
Ba.
you? Adama. Adama.
Yeah.
Okay. Let me check your result. Uh-huh. Adama, I see you. Adama Ba. Do you see? Or not?
I see.
Yeah, you see. So, question 1 correct is Adama Ba. Question 2 correct. Question 3 not correct. So you don't know algebra. What you see now, yes? But 4 and 7 not good choices. The good choices 2, 6 and 8. So check your algebra knowledge. Question 4 correct. Question 5 correct. Question 6 correct. Question 7 correct. Little bit difference, but very close. Question 8 correct. No, again, for some difference, I don't know how a system will accept or not accept. Is 1% different, it will accept. Greater than 1, from 1 to 5%, it will give you 50% of grade. Greater than 5% will not accept. Okay, question 9 correct. Question 10 very close, not exactly. Question 11 big difference, no correct. V final. No, problem is easy, no secret, it's standard formula. M1 times V1 plus M2 times V2 divided by M1 plus M2. My guess, maybe you forget that V2 is negative. Maybe this is the reason. So you made mistake in calculation. Question 12. What question 12? Again, mistake in calculation. Mass M1. No, I don't. In question 12, my guess why you have mistake, because you didn't focus that velocity 2 by y direction. So you have to use this Pythagorean theorem. This V final first you have to find the what. Okay, the collision is completely inelastic. Inelastic, what is elastic? So horizon of the horizontal axis x collides with the mass m2 moving at the speed 2 in the direction of the horizontal axis y. So we have two horizontal axes, but in any case they are perpendicular to each other. So you have to do what? Is V final. So you have to do m1 times v1 total squared plus m2 times v2 total squared, take from this root squared and divide by m1 plus m2. Okay, I will show you now I will calculate for you. So we have my answer, I will take this. Now I will go to Google Sheet to show you calculation. What is a Google Sheet? You don't see. Now I will make it visible. I know. Okay, now I will change screen to show you. So now I in Google Sheet. So what I write your number, you see, M1, V1, M2, V2, we have to find V final, and we remember is a perpendicular direction. This is one X direction, another Y direction. So formula for V final. Okay, I start to do this formula. Equal SQRT, because we will use Pythagoras theorem. Then M1 times V1. Okay, but before I have to what I started already. Okay, copy, paste here. Because I have to write data without only numbers separately. So I have to do numbers separately without unit and without name of variables. V565 922 2.8 and minus 8.94. What numbers? I have numbers. Velocity final equal SQRT. Then M1 times V1 squared plus parentheses M2 times V2 squared, parentheses close. This is already total momentum after collision, magnitude of total momentum. To find velocity, we have to delete by total mass. To delete by M1 plus M2. Now my guess will have velocity final good number. Let me check. I have to click enter and I have number. Now I will make from this number only 3 significant figures and do like this. And I have 7.16. What have to be your answer? 7.16, exactly what we need. Do you understand? That's why, because X direction and Y direction, perpendicular, we have to use Pythagoras theorem.
Yeah, I see my
Okay.
I see my mistake. I input the negative 8.94 when I was putting the calculation, and I forgot to square root it.
Okay. Question 13. Not correct. What? Question 13, not correct. Because in question 13, we don't have mass, but mass cancel it. This formula for velocity final, this is in parentheses v1 plus k v2 parentheses close divided by 1 plus k. I derive this formula for some another student. What again? What write? In parentheses you have to write v1 plus k v2. Because k v2 is multiplication v1 plus k v2. Total in parentheses divide by, in parentheses, 1 plus k. Because mass cancel it. Okay, will you try to calculate? So is a question 13. Question 14 correct. Question 15, no, close, but not exactly. I don't know why. My answer 10.7, your answer 11. Question 16. Close, very close. Not exactly, but very close. So you see, no, what? Do you need some explanation or it's enough? You can write by yourself to continue, to check your mistake. What mistake? This 14 mistake. No, not 14. 13 is mistake.
Yeah, I'm gonna try.
You try, yeah. Okay, what time? 8:31. No, any question? Do you have more students here or not?
No, it was just me.
Just you.
Yeah.
Okay, Adama. Adama, your name is Adama, yes?
Yeah.
I see you what? Your child close to you, yes?
No, that's
It
my
helps you.
that's my sister.
Ah, your sister.
Yeah.
Okay. Okay, Adama, if you need my help, I can help you.
No, I think that was it. I'm gonna try it.
Okay.
Have a
Okay,
good
Adama. So, goodbye.
night.
Good night. Good night. I finish my session. So I go to this.